If you're looking for an easy way to get detailed information about your computer's hardware, like you'd see in the Windows Device Manager, this open source Linux tool is what you need. In this video, I'll show you how to install this useful utility using the package manager on Ubuntu, Linux Mint, and other Debian-based distributions. I will also give you the details to install it on other types of Linux distros. I'll give you a tour of the user interface, so you can see how to access specs and benchmarks for your CPU, memory, graphics card, storage, and more. We'll run some system performance benchmarks, so you can understand your hardware's capabilities. And I'll demonstrate how to export full reports to HTML or plain text files. Whether you're a beginner looking to learn about your machine, or a senior user diagnosing issues, this tutorial will help you install and master an invaluable graphical device manager for Linux. You'll be able to reveal key insights and information about your computer's components. And you'll get a Linux equivalent of the Windows Device Manager, with detailed system profiling. So, get ready to install this handy GUI hardware info and benchmarking tool on your Linux desktop or laptop. Let's get started. This application's name is HardInfo and it's available in all major Linux distributions repository. It displays hardware and some software information in a neat graphical interface. Let's get HardInfo installed on our system. The installation process is pretty easy on Debian, Ubuntu, Linux Mint, and other Debian-based distributions. We just need to use the package manager. First, open up a terminal window. Then we'll update our package index to make sure we have the latest list of software. Type in sudo apt update. Great, now the package index is refreshed. Next, we actually install HardInfo by typing sudo apt install HardInfo. And that's it. HardInfo is now installed on our system. The package manager makes it super fast and straightforward to get HardInfo up and running. Now we can launch it from the Applications menu, under System Tools. Just search for HardInfo, and click to open it. When it starts up, you'll see the main interface showing a summary of information about your CPU, memory, operating system, etc. We'll explore the different sections in more detail soon. If you're using another distribution like Fedora, CentOS, Arch, or Manjaro, I've included instructions in the video description for installing HardInfo on those as well. The commands are a bit different depending on the package manager, but I've got you covered. So be sure to check the description if you're not on a Debian-based distribution. Let's start by opening the HardInfo application. The first screen you see provides an overview of the operating system, kernel, CPU, and memory. This gives you a quick snapshot of the core system details. Operating system shows details on the operating system name, version, distribution, etc. Security displays information related to the system's security settings and configurations. Kernel module displays the loaded kernel modules, their size and status. This is useful for debugging driver issues. Boots provides information on system uptime and number of boots. Languages provides information related to the languages and locales supported by your system. It gives you details about the installed language packs, language settings, and language-related configuration on your Linux distribution. The memory usage section gives you insights into the memory usage of your Linux system, allowing you to monitor the overall memory usage, identify potential bottlenecks, and assess the availability of free memory for optimal system performance. The File Systems section gives you a comprehensive overview of the file systems present on your installed Linux distribution. It allows you to monitor storage usage, understand the file system types, and assess the health and status of your storage devices, such as whether they are mounted read-only, read-write, or if any errors or inconsistencies are detected. Display provides information on the graphics card, drivers, resolution, pixel depth, etc. Environment variables lists all configured environment variables. Development shows installed development tools and libraries on the system. Users Groups displays configured users and groups along with user IDs, group IDs, and home directories. Here the DMI stands for the Desktop Management Interface. The System DMI gives you detailed information about your system's hardware and firmware. It includes details such as the system manufacturer, model, serial number, BIOS version, and other system-specific information. This section is particularly useful for identifying and verifying the hardware components of your system. The Processor section provides information about your system's CPU. It displays details such as the CPU model, architecture, clock speed, cache sizes, and the number of processor cores and threads. Graphics Processors section displays details about the installed GPUs, including the GPU model, manufacturer, driver version, and other relevant information. It can be helpful for identifying and troubleshooting graphics-related issues, as well as understanding the capabilities of your GPUs. Monitors provides information about the display devices connected to your system. It displays details such as the monitor model, manufacturer, resolution, refresh rate, and the connection type. This section allows you to view and verify the specifications of your monitors. Memory devices. This gives you information about the memory devices installed in your system. It includes details such as the type of memory installed, the capacity, clock speed, and other related information. PCI devices. This displays information about the PCI devices connected to your system. It lists the various devices connected via the PCI bus, such as graphics cards, network adapters, sound cards, and other expansion cards. USB devices. In this section, you can find information about the USB devices connected to your system. It lists the USB devices detected by your system, including external storage devices, input devices such as keyboards, printers, cameras, and other USB peripherals. The firmware section provides details about the firmware present in your system, including the BIOS or UEFI firmware. It displays information such as the firmware version, manufacturer, and release date. Printers. This displays information about the printers connected to your system. It provides details about the installed printers, including the printer model, manufacturer, and status. Battery. If you're using a laptop or a portable device, this provides information about the battery status. This shows details such as the battery capacity, charge level, and power status. Sensors. This displays information about various sensors present in your system. It includes temperature sensors, fan speed sensors, and other hardware monitoring sensors. The information can be useful for monitoring system temperature and fan speeds. Input devices. In this section, you can find information about the input devices connected to your system, such as keyboards, mice, touchpads, and other pointing devices. It provides details about the device manufacturer, model, and other relevant information. Storage. This provides information about the storage devices in your system, including hard drives, solid-state drives, and other storage media. It displays details such as device capacity, model, serial number, and file system type. The Resources section provides an overview of the system resources, including CPU usage, memory usage, disk usage, and network activity. It can give you a real-time snapshot of how your system resources are being utilized. The Interfaces section provides information about the network interfaces present in your system. It displays details such as the interface name, MAC address, IP address, subnet mask, and other network-related information. This section allows you to view and verify the configuration of your network interfaces. IP connections. This section displays information about the active IP connections on your system. It shows details such as the local IP address, remote IP address, port numbers, and the state of the connection. It provides insights into the current network connections established by your system. This displays the network routing table of your system. It shows the routes used by your system to determine how to forward network traffic. It includes details such as the destination network, gateway, netmask, and interface associated with each route. ARP table. ARP stands for Address Resolution Protocol. It displays the ARP cache table of your system. It shows the mapping between IP addresses and MAC addresses for devices on the local network. It includes details such as the IP address, MAC address, and interface associated with each entry. DNS servers. This section helps you to verify and check the DNS server configuration. Statistics. This provides network statistics for your system. It includes information such as the number of packets sent and received, network errors, collisions, and other network-related statistics. This gives you insights into the network performance and usage of your system. Shared directories. This displays information about the directories shared by your system over the network. It shows details such as the shared directory path, permissions, and other relevant information. Alright everybody, let's talk about benchmarks. A benchmark test is a way to measure and compare the performance of computer hardware or software. Benchmark tests put a system under a controlled simulated workload and measure how it performs. Benchmarking lets us objectively compare performance between different components. So it helps answer questions like, which graphics card gives me smoother gameplay? Or, which SSD drive loads apps the fastest? Benchmark numbers take out the guesswork, so you can see the real-world speed differences between parts. It's a handy tool to know exactly how speedy your PC is. By the way, if you find this video helpful, I'd really appreciate if you could give it a thumbs up and subscribe to the channel. It lets me know you want to see more content like this, and it also helps YouTube to understand that people are finding this video useful. The more likes and subscribers I get, the more likely I am to create more tutorials in the future. So please take just a moment to click that like button and subscribe. It really helps me out, and I appreciate all of your support. Anyway, back to the benchmarks. HardInfo includes several benchmark tests targeting different components. Let's look at what these benchmarks measure. CPU blowfish. CPU blowfish benchmarks evaluate the performance of the CPU using the blowfish encryption algorithm. There are single-threaded, multi-threaded, and multi-core tests. Single-threaded focuses on one CPU core. Multi-threaded uses all cores, but one thread per core. And multi-core uses all cores, with multiple threads per core. CPU zlib. CPU zlib benchmark is a test that measures the compression and decompression performance of the CPU using the zlib library. Zlib is a widely used software library for data compression, known for its efficiency and compatibility. CPU crypto hash. The CPU crypto hash benchmark is a test that measures the cryptographic hashing performance of the CPU. Cryptographic hashing is a process that takes an input and produces a fixed-size string of characters, which is commonly used for data integrity checks, password storage, and digital signatures. CPU Fibonacci. CPU Fibonacci calculates large Fibonacci sequences, stressing recursive CPU performance. CPU N-Queens. This is a test that measures the CPU's performance in solving the N-Queens problem. The N-Queens problem is a classic mathematical puzzle that involves placing n chess queens on an n into n chessboard, in such a way that no two queens threaten each other. The goal is to find all possible solutions for the given n. When you run the CPU N-Queens benchmark, it performs calculations and iterations to solve the N-Queens problem, using different algorithms or techniques. The benchmark assesses the CPU's speed and efficiency in finding solutions to the N-Queens problem, and provides results in terms of the number of solutions found per second. FPU FFT. The FPU FFT benchmark refers to the floating point unit, fast Fourier transform benchmark. This benchmark specifically evaluates the performance of the floating point unit in your system by measuring its ability to perform fast Fourier transform calculations using floating point numbers. FPU ray tracing. The FPU ray tracing benchmark is a test that checks how well the floating point unit in your CPU can handle ray tracing calculations. Ray tracing is a technique used in computer graphics to create lifelike images by simulating how light bounces off objects in a scene. Sysbench CPU. When you run the Sysbench CPU benchmark in HardInfo, it executes a series of computational tasks designed to stress the CPU. These tasks involve mathematical calculations, integer operations, and floating point operations. It measures the execution time of these tasks, providing insights into the CPU's performance in terms of processing speed and efficiency. This test assesses the CPU's capabilities in terms of single-threaded and multi-threaded processing. Sysbench memory. When you run the Sysbench memory benchmark in HardInfo, it performs a series of memory-intensive tasks to evaluate the memory subsystem's capabilities. These tasks involve operations such as reading from and writing to memory, copying data, and performing memory allocations and deal locations. Now, let's run a benchmark test and save the result as a HTML file. I hope this tutorial helpful for you. If you enjoyed this video and found it useful, I'd really appreciate if you could give it a thumbs up and subscribe to the channel. Your support helps me to keep making more tutorial videos like this one. Thank you so much for watching, and I'll see you in the next video.